It's time to continue with our study of exponents. We already have several rules laid out, and we need to establish at least a couple more. Now, you may have noticed that when you were using your quotient rule of exponents, that maybe at first or at times you were tempted to come up with a negative result. Let's look at how that might happen. Let's say we had a k to the 8th over a k to the 11th. Now, strictly speaking, the way this rule is written, it says n minus m. Never says to do m minus n. But what we were doing is we were saying the biggest power is 11. 11 minus 8 is 3. Put a k to the third on the bottom and put a 1 on top just to hold a place for the numerator. But again, this is strictly not the way the rule is supposed to be used. Let's go back and look at this problem using definitions again. A k to the 8th over a k to the 11th, according to the definition of exponent, would be 1, 2, 3, 4, 5, 6, 7, 8 k's on top. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 k's on the bottom. And when you start canceling, I think you can clearly see that the result we got was in fact correct. But again, that's not what the property said. If we work this problem one more time, using the property, exactly doing what it says to do, this is k to the 8 minus 11, which is not k to the third, it is k to the negative third. So what we've ended up with is a negative exponent. Now, does that mean that the quotient rule is wrong in some way? Actually, no. The fact is that these two answers are actually the same thing. When you use the quotient rule and you get a negative exponent, or anytime you have a negative exponent, what is implied there is that this base is on the wrong side of the fraction. This base, as it is written right now, is in the numerator's position because you don't see another numerator over top of it. You can always assume a denominator of 1. So this k is in a numerator, but the negative exponent says it's in the wrong place. Anytime you see a base with a negative power, you simply need to take that base, move it to the other side of the fraction, and make the power positive to say it has been moved, it is now in the right place. And again, if there's nothing else to put in a numerator, you can always put a 1. We can generalize this in a rule. And again, my rule, the way I write it, has a couple of parts to it. I say that x to the negative n should be rewritten as 1 over x to the positive n, and I add to that 1 over x to the negative n should also be rewritten and made into x to the positive n. So no matter which side of the fraction you are on, if the exponent is negative, you need to move to the other side of the fraction. So let's see another example of that being done. Clear everything up first. Alright, let's take a look at a 5 to the negative third power. Alright, where is it now? Is it in a numerator's position or is it in the denominator's position? Well, it's in a numerator because you see no other numerator over top of it. So, there's where it is. It is on top. I'm going to move it. Put it in the bottom. Power goes from negative to positive because now it's in the right place. What do you have for a numerator? Nothing? Well, okay. Put a 1 up there. And go ahead and take 5 to the third power. 5 times 5 is 25. Times 5 again 125. Alright? Let's turn around and do it in the opposite direction. Let's say I had a x squared over a y to the negative 3. Let's take a look at things one item at a time. X squared, positive power. Leave it alone. Y to the negative 3, negative power. It's in the wrong place, so move it. Now the power becomes positive, and you don't have a denominator anymore, and you really don't have to have one, so that's okay. Another example. X to the negative 3rd over x to the negative 5th. Alright, let's take a look. This on top, negative power. It's in the wrong place. Move it. Make the power positive to say it's been moved. On the bottom, negative power, wrong place. Move it. And then, quotient rule again, 5 minus 3 is a positive 2. You see, it is incorrect to leave negative exponents behind. That's considered not simplified. All right, let's try another one. Z to the 9th times z to the negative 12th. And as we said before, do you have to use one power in particular before others? No. If you wanted to, you could add first. 9 plus negative 12 is negative 3. And then move afterwards. And that will work out just fine. Okay? Let's try a couple more. Negative 6 to the negative 2nd. What do we have? Well, this one's going to be a little bit tricky, so watch carefully. The negative sign. There are no parentheses here, notice. We talked about this before. No parentheses means the negative stays behind as a negative 1. The 6 has negative power, so it moves. Power becomes positive. Negative 1/36 is your result. Alright, let's try another one. Let's take in a fraction. We'll say it's being raised to the negative 3rd power. We will put in a on top and a b on the bottom. And we will use that property that we said looks like the distributive property, even though that's not what it is. This becomes a to the negative 3rd over b to the negative 3rd. Okay, where does everything need to go? Let's see. A's in the top. It has a negative power. Therefore, it's in the wrong place. Move it. B's in the bottom. It has a negative power. Therefore, it's in the wrong place. Move it. Now everything is exactly as it should be. And actually, this particular example gives us one more rule. We can go on to say that if you have an x over y to the negative n power, the effect that negative power is going to have is going to be to basically just reciprocate that fraction. So we finally got all of our rules. Let's go back to the examples finally and look at 2 or 3 more examples using the rules of exponents along with the negative exponents. Everything cleared up over on this side. And look at another example. Let's take a negative 5 x squared y to the 6th over a x to the 7th y to the negative 8th and raise it all to the negative 3rd power. Alright, again, we have several different rules that we could use for this. You do not have to use them in any particular order. We'll just pick one to use first. Put my y back a little bit neater. And like I've said before, I think I'll simplify inside the parentheses first. So, here we go. Negative 5, it's okay where it is. We said that negative exponents get moved. Negative numbers do not. You do not take a negative 5 and turn it into a 1/5. Alright, 2 minus 7 would be an x to the negative 5th, or you could go ahead and write it as x to the 5th on the bottom. And the negative 8, we have a y to the 6th, which stays where it is. A y to the negative 8 that comes up as a positive 8, and I'll worry about the negative 3 in a minute. And we put together what we can. We're going to have a negative 5, y to the 14th, x to the 5th, Now let's deal with the negative part of the negative 3 power. The effect that that negative has is to simply reciprocate. And now the power rule. 5 times 3 is x to the 15th. Negative 5 to the 3rd. Well, let's see what that's going to be. Calculator can help us. In parentheses, a negative 5 to the power 3. And come out a negative 125. Of course, that's on the bottom. And 14 times 3 for your power rule is a 42. So this can come out as a y to the 42nd power. So there are the last of your rules of exponents and a few examples of each. Exponents can be a point where a lot of students get stuck, especially if they've never seen them before. So make sure to spend extra time on this topic.